course agenda. The agenda is, but not limited to, the following. First, we'll be discussing the security considerations for Linux components and functionality. Then we will identify and describe threats to the Linux OS. Additionally, we'll identify and describe tools used to mitigate threats in the Linux OS. And finally, we will apply these tools you learn to harden the Linux clients and servers that we will eventually have to protect. So let's take this agenda and transform it to our goals for the class. As you'll see, each one of the goals matches the agenda. And learning to discuss security considerations for Linux. Why is that important? And so in response, Linux systems support over 10% of the global economy. So what does that mean? Well, unbeknownst to most of the general public, Linux happens to be ubiquitous across the globe with regards to any discipline, manufacturing, retail, finance, because it is the underlying infrastructure OS of choice for many of these large behemoths that these companies subscribe to, such as Google, AWS, Twitter, Facebook, you name it, whatever they're using in marketing or storage or backups or a variety of email services, 9 times out of 10, it's going to be a Linux OS that actually governs that particular piece of architecture. That being said, there's also the presence of Linux being in Android, all your Android phones, all of the IoT devices, such as your television, your microwave, your refrigerator, whatever prescribes to put in a intelligence in any kind of object that is connected to the internet. And so as such, because of the Linux reliability, as well as its efficiency and the ability to reduce its size to work effectively, Linux is the one of choice. And so as the goal for identifying and describing threats to Linux OS, of course, if you can't protect what you don't understand. So understanding how Linux works and the threats and vulnerabilities will help you secure Linux. I'll go as far as saying if you can't protect against something you don't understand. And so we will walk you through that. The third bullet point, identify and describe tools used to mitigate threats in the Linux OS. Well, the importance of this is addressing vulnerabilities and threats requires knowledge of the tools. And so naturally, you can't, in this kind of world, things happen so fast and it's such a tsunami order of magnitude. You need tools to just keep up, if not to protect at the very base minimum. The concept of not using tools is ridiculous. You would be unarmed with regards to the attack vectors that are coming at you and the understanding of the vulnerabilities of your attack surface. The fourth one, apply tools you learn to harden security for Linux clients and servers. Naturally, knowing the Linux security will be a valuable asset to your employer, but it also allows you to not only mitigate against the impending tsunami of attacks, but actually harden for proactive mechanisms to make sure that it doesn't happen in the future. And not only that, the fact that you won't have to be actively present for to understand that the system is protected. That's why we harden, quote unquote. Right now, the just for as an auxiliary note, as addressing the 10% of the global economy, just know that roughly, far as servers as well as presence on the internet in general, Linux probably has by now, if not 75 to 80% of the entire infrastructure for the internet. So just knowing that shows the relative importance of you to understand Linux in detail, because if you're going to protect the enterprise, Linux is a big part of that, whether you have it directly in the organization or not, because they obviously subscribe to services out there in the wild. Okay, so next is the introduction of Linux security. And no introduction would be complete without mentioning the anthology of Linux. And so let's go back in time and walk through what was happening during the time that Linux was actually invented. As for history snippet, in the 80s, Microsoft DOS was the dominant OS for PC. In fact, on July 27th, 1981, Gates fully licensed the quick and dirty operating system, QDOS, from a company called Seattle Computer Systems. And the OS later would be known as MS-DOS. They first started out with a non-exclusive deal, but then shortly thereafter, they went ahead and spent $50,000 and bought it exclusively for Microsoft, because at the time they figured out, Paul Allen and Bill Gates both thought it would be best to buy it rather than build it. Then at the same time, Apple Mac was actually a better OS, but it was too cost prohibitive for the masses. Unix was even better than the other two, but then was only available on a MicroStation platforms predominantly. There was an effort to push Linux on the desktop, but the licensing was too cost prohibitive, so it just didn't make any sense. But that, as far as MicroStations are concerned, for those of you who are not familiar, back in the day, and there are some CAD/CAM systems that are still out there that run, the manufacturer design 3D graphics kind of things. And back in the day, they had these called MicroStations, and the 3 or 4 predominant players were Apollo. Apollo had Aegis POSIX, and then of course Sun Microsystems had their Sun Unix flavor Solaris, and then I think it was System 5 first, and then they made their own flavor called Solaris, which was better, faster, stronger. And then there was 2 other machines that were run by Lisp, and this was an AI infrastructure kind of thing. And I mentioned Lisp Machines Inc. and Symbolics Inc. for a good reason. In fact, Symbolics Lisp was the first, in 1985, the first .com company out there, Symbolics. Interesting enough, all the players out there, DOS, Mac, Unix, were all proprietary, Lisp, of course. And the source code of the kernel was protected, hence no modifications were possible without paying a huge licensing fee, which wasn't really desirable for those days' economy. That being said, there was an interesting movement, and how this all ties to Linux, we'll see. Yeah, the mentioning of the MicroStations, remember the Lisp, the AI-driven architectures, the Lisp Machines Inc. and Symbolics Inc. Well, it so happens that they were both spinoffs from the MIT AI labs, and there were a group of developers there at MIT known as the hackers. And between the two, Lisp Machines and Symbolics, Symbolics attracted more of the hackers because they had more funding and engaged in business with them more frequently. That being said, the tactics used by Symbolics, because normally they would, the hackers in MIT's AI lab would further the precepts of Lisp and features and functions, and give them to both the Lisp Machines and Symbolics. And both those guys were really former alumni. The founders of those particular companies were former alumni, and they had 2 disparate philosophies, but that we won't get into that. The whole point is that Symbolics had engaged in some business tactics which forced the MIT players to make all Symbolics copyrighted fixes and improvements not available to the competitor, the Lisp Machines. As such, Lisp Machines went toes up, and so ended the collaboration between the hacker community and the Lisp Machines. Well, as it stands, Richard Stallman, one of the players there, actually quit the group and moved on, and was so incensed by the way Symbolics Now, there's two stories. There's one floating around about he wasn't able to modify a printer to his liking because of the new concept of proprietary code, and you can't see it. That's one story. But the one I've known ever since day one, where I was in the industry and I was there, the story goes that Stallman was so incensed by the fact that Symbolics did the business tactics as such by grounding the ball and saying, no, none of these enhancements to Lisp will be available to the Lisp machines. And as such, Stallman said, well, okay, that's it. I'm going to start what the new project, and the new project, GNU, a new project to make a new community, eventually deriving a new public licensing contract called copyleft. Copyleft would ensure that hacker software could remain free software. In this way, if you think about it, Symbolics in their dastardly deeds, albeit adversarial role, did culminate the concept of free software movement or open source. So that's the connection. And the new general public license is the actual license that Linus Torvalds took and used for Linux. And as such, the whole world participated in the development of Linux, and what made it so robust and feature rich, because you've got thousands and thousands of players contributing to its evolvement. So at this juncture, are there any questions you may have with regards to the concepts of the 1980s having cost prohibitive licensing issues? So it took a while to embrace the concepts of a open source operating system such as Linux because of the cost associated with licensing, and that micro stations, or in those days they called them workstations. The dispute at MIT's group with the Lisp machines, the Symbolics versus the Lisp Machines Inc. Debacle, inspired Richard Stallman to initiate the new licensing project, and as such, opened the doors to what we now know as open source software. So, is any questions about that? Any clarifications I can make? All right, then we will move on to open source software. So what is open source software? And so thanks to Richard Stallman, we have open source software, aka OSS. You have access to the plain text source code because of the concept of open source software. And that can be used to build your software. You can enhance your software, you can add to it. And so to put it straightforward, the concept between proprietary software and open source is the fact that you have access to the source code, that you can allow to modify it, enhance it, build upon it as you see fit, unless you are a commercial entity, whereupon you must contribute to, I believe, the community itself with large donations, as well as, I believe, adopt a licensing fee. The whole idea of the open source software being protected by the public licensing fee was to ensure the community sustains sustainability, and as well as no giant behemoth computer company that could abscond from their hard sweat and contributions over the years and then make a profit from it. And this is the type of thing that needs to be explained. And that's what happens in the design phase. As you move on to the build phase, during the build phase, development teams are coding the solution. They're packing away, and developers should be using secure coding practices as well. Like, okay, if you are going to send data over, make sure you encrypt it before you do so, and then have some kind of validity when it arrives, so they can do a checksum, compare the checksum, or some digital signature of some sort, and say, okay, it hasn't been perverted since I received it. Okay, so that being said, this is where a good uh, um, static application security testing tool could be in place. And the SAST, S-A-S-T, is a term given by OWASP. You know, that's the organization we talked about earlier that is the top 10. And they have this thing, and they have a list of tools, which we have here, have graciously provided in the deck, a slide deck. So here's the list where you can go and find several tools that are used to analyze code against CVEs and security pitfalls. And all of them there are listed with the accompanying number of, or number of languages they support. So that's pretty handy, and please enjoy that. So now it moves us into the test phase, where the application is ready to be checked for functionality and attacked in a secure way to test the security methods implemented. And this is where post-compiled test scanners can be deployed as part of the validation process. In addition, an external or external pen tester may be engaged to attack the application, just as a criminal would do to catch any possible vulnerabilities that are still exist, even with all the checkpoints that have been deployed. And that being said, that's where I was mentioning the use of the tool Falco. Falco produces that it will post-compile test, and this is where that would be deployed. Speaking of deployed, this is our next step, where deploy and maintain. The application has reached the end of its build and now is deployed and in use by the endpoint customer, ideally with robust security checks and controls implemented through its SDLC process. So periodic penetration tests may be in order or even mandated. In other words, once a quarter, you do a pen test, a soft run, so you could see. And at the end of the year, you do a full-blown pen test. Regular reviews of dependency and security and scrutiny of customer feedback can help head off uncaught or new risks at this stage. Any questions with regards to this particular set of information with regards to where you would put the stopgaps in for secure software testing? Any comments, requests for clarifications, or whatnot? There are many applications security controls and practices available, and to perform an online search of a discover a tool, practice, or framework to discuss further. In other words, I mentioned Falco. However, there are others. This is where we can provide some insight with regards to what are other sources of applications that can supply security in an SDLC environment, in this case, post-compiled, because I gave you a list for the pre-compiled, and it would be nice for post-compiled. We'll assume this goes for 5 minutes and then move on. Oauth Zap. Now, we know all familiar with OWASP, and that was the organization that was a nonprofit provider for our top 10. And the top 10, OWASP standing for Open Web Application Security Project. And these folks have a Oauth Zap, which happens to be a attack proxy, a Z attack proxy to be specific. And it's an open source application scanner available at zapproxy.org with only 1P. It's capable of automated or manual testing in the SDLC, and CLI or GUI interfaces available, but very beginner friendly. It has a nice GUI interface. And passive and attack scanners. And when passive is where they're just listening, and active scanners where they would actually go and scan particular reports and whatnot. And a Spider and more are available with OAuth. Spider being the crawling along the entire distribution tree of your site, and then have all the respective directories that are connected to it. And it records all actions taken against your app in the database and analyzes it for review. So that's what Oauth Zap does. A mobile-only version of software. B, a program that runs only through the command line interface. C, a program designed to perform a function or set of functions on a computer. Or D, the use of software in social media. And go ahead and answer in the chat. I will go ahead and. Okay, yes, the answer is C, a program designed to perform a function or set of functions on this computer. Interesting enough, even though this is a Linux security thing, it's really dedicated to software development. But that being said, it doesn't mean it doesn't apply, right? It shows that the Linux facet is just as much ingrained to the mechanics and the governance of software development as a whole. And in fact, it isn't specific. The tenets of software development apply to everyone, including Linux. But in this program, this is where we address it. And so that being said, question 2, a progressive web application is, and although we didn't discuss this, but I think you can derive this by just looking at the answers. Many times when you do these questions, you may not know the right answer, but you definitely can figure out which ones sound wrong. So A, a progressive web app is A, an application designed to the highest performance standards. B, an application designed to work equally well on desktop and mobile interfaces with the same code base. C, a piece of software designed with ADA compliance at the core features. Or D, an app that contains step-by-step walkthrough screens for new users. Anybody have venture a guess in their chat? Yes. Yeah, right away. You guys jumped on this one. B, yes. An application designed in a progressive web app is one that works equally well on a desktop or mobile interfaces. Why would that be an easy guess? Because that's what you find where applications now no longer just are exclusively to the desktop. Now you find the mobile contingent, and the mobile contingent 9 times out of 10 works exactly like the one on the desktop. A reason being is you don't want your users to be frustrated with having to learn different methods or techniques to address the same application on a different platform. Anyways, excellent, well done. Well done. Question 3, blank is not a regular vulnerability on OWASP top 10. Now, A is misinformed users, B, insecure design, C, server-side request forgery, or D, broken access controls. So which one of those did you not see me or hear me describe in the detail? And you guys are all over it. Yeah, A, very well done. Yeah, we weren't fooling anybody on that one. Okay, fine. The next question. Blank is not a step in the SDLC. And is it A, fuzzing, B, test, C, build, D, plan? Yeah, fuzzing was not. And in fact, fuzzing was mentioned in the fact that it is part of the testing type. Fuzzing test in description. You have heard the term, but just in case, for those of you who need a refresher, fuzzing is when you input information in a field that it's not expected. In other words, what you're really kind of testing is what will happen with this application if I put in this, or this, or maybe a tick, right? Or 1 = 1 dash dash, what's going to happen? Is it going to give me all the database information, or is it going to say, hey, this is improper? And that doesn't have great input filtering, that kind of thing. That's what fuzzing is. Fuzzing is testing by putting esoteric input fields, a variety of characters and numbers and whatever it takes to see if you can, one, break the application, or two, get a response that is unexpected. Remember in the video, the one guy put in a tick mark and it said right away, the error said, hey, your SQL command was malformed. And so that right away, it told that guy, right now it's accepting SQL commands in this login box. That means maybe I should try the tautology SQL injection. And he tried it and it didn't work, but he wasn't thwarted then. He said, no, I know what's going on. I need to encode this. Now, so he encoded it with URL and it worked. Now, the way he was doing this was, I believe in the Burp Suite. And in Burp Suite, he was doing it from inside the communication code. See, where I was demonstrating was in the actual password field. And that is encoded in via URL. But inside the actual messaging, he had to encode it to URL because he wasn't coming in from an input field on a web page. He was coming in from the actual frame mechanism that sends the message over. So it had some post-processing necessary, which in this case was URL encoding that encoded the tick mark or 1 = 1 dash dash. So when it was sent over, it digested it like it's supposed to. And, that's part of the post-processing that happens when you enter it just in text in a input field on a website. It goes ahead and does URL encoding and then sends it off. And so that being said, fuzzing, yes, fuzzing is not a step in SDLC. Excellent. Zoom quiz during these two phases. First of all, this is software development lifecycle. Unfortunately, fuzzing is a specific type of testing, and they already have it covered in test. So that would also be, if you're wondering, have I ever seen that? This also helps. Okay, so Zoom quiz during these two phases of the SDLC. The primary security control is communication. Now, remember in the discussion, I said, that these two are combined together, and this is where your soft skills come in. That's where the purple team finesse, the kung fu, to make sure that you're communicating appropriately to this level. What was that level? A, test and deploy. B, deploy and maintain. C, identify and plan. Or D, design and build. I see some D's, and then the rest of you are all C. C is the correct answer. Very well done. Well done. C, identify and plan. Excellent job. Okay, next question. Shift left testing refers to A, incorporating political ideologies into software development. B, developing on multiple screens, right? C, using penetration testing tools at each step of the SDLC. Or D, incorporating security controls and considerations at each phase of the SDLC. Yeah, nobody's fooled on that one. D, yes, incorporating security controls and considerations at each phase. Yeah, these are kind of wild. First of all, they're all like throwdowns. Political ideologies, I don't think so. Haven't discussed it. Develop multiple screens, what? Right? And using pen testing tools at each step of the SDLC. Ooh, so D really is the only answer that actually even closely makes sense. All right, so the next one here. What is DevOps? Okay, what is DevOps? A specifically trained unit of government developers. We'll skip that one. B, a set of practices designed to avoid delays and bugs by incorporating IT and development teams during the SDLC. C, incorporating security controls and considerations each phase of SDLC. And D, a buzzword designed by marketers to sell new services. Yeah, I know it's B. Yeah, everybody's already asked. Before I even get to the rest of them, they're all like B. All right, excellent. So questions. So we're finally at the end of this lecture. I hope everybody had a good time. With the illustrations in detail and all that jazz. So we're early at 2:31. We still have an hour left, but that's the good news, is that there is the second lab, and that's probably what the hours why we're an hour early. But that should be taken care of quite readily. Anyways, other than that, we'll summarize what we did. So in summary, in this lesson, learners acquired a basic understanding of application security. They should know how to be able to differentiate between software and infrastructure security concerns, discuss security coding practices and vulnerabilities, and recognize the difference between common tools and controls. And I believe you all can do that. So, and if there's not any questions, comments, high fives. All right. If not, we thank you for your time and patience. It's always a pleasure to teach you folks. Being so bright and encouraging, inspiring, if I may. So that being said, we wish your horizons to be all bright and bushy tail, and then we will see you next time when we get together. Have a good one. Thank you very much. Bye-bye.